Good afternoon. Today we're going to look at operations on functions, difference quotient, and composition of functions. And we'll start off with operations.
So we're continuing that discussion of functions that we started a long time ago. Well,
right. Operations. Now, when I talk about operations on real numbers, I mean addition, subtraction, multiplication, and division. Those same operations can be extended to the notion of functions. It's addition, subtraction, multiplication, and division. I'll put the little division symbols for there, but let's look at number one. I'll tell you right now, addition, subtraction, multiplication, and division functions are generally written as algebraic equations. So addition, subtraction, multiplication, and division is really just algebraic addition, subtraction, multiplication, and division. What I'm trying to say is that those first four operations, they're really nothing new. It's just a matter of how we're going to denote them. Looking at number one, we have two functions. We have f of x equals 3x plus 2, and g of x is equal to 2x minus 5. Notice the instructions. They want us to find inside the parentheses. It's f plus g of x, f minus g of x, and look at that third notation there. It's just fg. That's, if you don't see an operation, that's assumed multiplication. So that's said f times g. And then division, they're denoting with the fraction bar, f divided by g. Once we find all of those, they want us to give the domain of each function. Let's see if anyone remembers. We mentioned this in class the last time. We mentioned it 2 weeks ago, the Wednesday before spring break. Look at these functions. They don't ask us for their domains, but just for the record, while we're looking at them, what would their domains be? I see no fractions, no square roots, unless you're told otherwise. What do you assume the domain is for each of these functions? All real numbers. And that'll be important when we're ready to find the domain of f plus g, f minus g, f times g, and f divided by g. I'm going to make a note of these. Both of those have domain all real numbers. So here we go. F plus g.
Look at how they have that written, the parentheses.
Parentheses f plus g of x. Okay, switch to my paper. Notice I made a note. Both of the original functions have domain all real numbers. For f plus g, what they're saying to do is take f of x and add g of x. It's nothing it's nothing shocking. Take the rule for f of x and add g of x. Well, we know that f of x is 3x plus 2. I'm going to enclose 3x plus 2 in parentheses just to make the point that those two terms came from the original function f of x. And then we want to add g of x is 2x minus 5. Once again, I'm going to enclose them in parentheses just to show that it's make sure you see that 2x minus 5 came from g of x. 2x minus 5. We know how to remove parentheses. We know when removing parentheses, you look at in front of them and see, is there something there that needs to be distributed? Well, in this case, there's nothing in front of the parentheses. I guess you could think of it as a positive 1, but multiplying by positive 1 doesn't change anything. These parentheses are unnecessary. I'm just going to drop them. So I have a 3x plus 2. The same thing for the second set of parentheses. Well, I do have something in front of it. It's a plus. That's just like a plus 1. Multiplying by positive 1 doesn't change anything. So I'm just going to drop those parentheses. That's a plus 2x and a minus 5. Now in a moment, y'all be thinking about this. In a moment, instead of a plus, when we're doing f minus g, we're going to have a minus in front of that parentheses. So we're going to have to do something there. But for the time being, addition of functions is just algebraic addition. You know how to add these things. It's combining like terms. Addition and subtraction, you're just combining the like terms. 3x plus 2x, that gives me a 5x. And then my constant terms, I have a 2 minus 5, that gives me a minus 3. Any questions there? So the answer for f plus g is 5x minus 3. Tony, let's wait to...
Let's go ahead and find the domain right now.
Okay, we never do that. Let's do that.
You type it in later, but...
That's okay, I like that.
Look,
now remember the problem. When you're finding domains of functions, you have to make sure denominators don't equal 0. You have to make sure that there's no square roots of negative numbers. You can't just look at the final answer here. You need to look through the entire thing, because you could wind up with the square root of x in one function, and it could be squared or something. So you can't, especially if you're multiplying, so you can't just look at the final answer. Look throughout there. Do you see any fractions or square roots in that work? No. So you assume the domain for f plus g is all real numbers, negative infinity to infinity. Now let's do f minus g.
You want me to type in that answer?
Now, f minus g of x. That's saying, instead of f of x plus g of x, it's f of x, which we know is 3x plus 2. I'm going to skip that one line there. 3x plus 2. And we're going to subtract. Instead of plus, it's going to be a minus.
So that's the purple minus.
This purple minus is that purple minus there. And g of x is 2x minus 5. With f plus g, the parentheses were unnecessary. We had two unnecessary sets. We ultimately just dropped them. But with f minus g, one of those parentheses is not an unnecessary set. Looking at the first set, there's nothing in front to distribute, so that green parentheses, that's unnecessary. Just 3x plus 2. We'll drop them. But I told y'all to be thinking about this. Y'all tell me, what's going to happen? We have these parentheses, and sitting in front, we have a minus. What's that going to do? Which is going to do, it's going to have, what we have inside the parentheses is a positive 2x minus 5. Once we distribute through that minus, what are we going to have? A negative 2x. And the minus in negative becomes a plus 5. As I said, addition and subtraction, it's just combining like terms. If you were going to combine like terms, you have to remove the parentheses. There's a minus in front of the parentheses. You got to distribute that. Now we can combine like terms again. 3x minus 2x, that gives me 1x. What will my constant term be?
7.
Okay, positive 2 plus 5. I agree with the plus 7. For f minus g, look through all that work there. What's the domain? Do you see any fractions? Do you see any square roots there with f minus g? No, so what do you conclude the domain is? Negative infinity to positive infinity, all real numbers. Addition and subtraction of functions is just algebraic addition and subtraction of functions. Now, multiplication.
I'm going to go ahead and type in these two
Oh,
answers.
okay.
We don't want to get timed out.
You won't be able to type in the domains yet.
I know.
5x minus 3 and x plus 7. Okay, f times g. Multiplication of functions is just algebraic multiplication. They want us to find f times g. And as I said, notice they're not putting a little dot or x for times. If you don't see an operation, you assume it's multiplication. That's saying, don't tell them what they're going to do. I think these students can figure it out. We're taking f of x. That's just 3x plus 2. And we're going to multiply it by g of x. That's just 2x minus 5.
So you're just basically writing the same thing you wrote here without the purple plus and the purple minus.
You're right. How are we going to perform this multiplication? Foil it out. That's right. So do y'all see what I mean when I say that the operations on functions, it's just algebra. It's just a matter of notation. What does that thing mean, that fg?
It means foil this out.
It means take f, multiply it by g. In order to do that, you got to foil that out. You tell me, here we go. First, 3x times 2x, 6x squared, outer. 3x times a minus 5 is, okay, inner. 2 times 2x, last. 2 times negative 5 and negative 10. And we can combine like terms there. We have a 6x squared, negative 15x plus 4x, that's a negative 11x, and we still have that minus 10. What about the domain? Look through the work. Is there any time at which you would get an undefined result? By that I mean a denominator of 0 or an imaginary number, a square root of negative of a, where you could get a square root of a negative.
Are there any fractions or square roots?
So what do you conclude? Since there's no square root, there's no fraction. I remember
There's a square.
There's a square, but not a square root. Okay, so what do you conclude? Negative infinity to positive infinity for the domain. Once again, all real numbers. The square is okay. I remember a problem in the homework when we were looking at functions, which was the 2 weeks ago, when we were the Wednesday before spring break, yeah. And it had a square in it, that's fine. No square roots, no fractions, domain's all real numbers. And finally, f over g, f divided by g. Notice they're denoting notice how they're denoting that f divided by g. They're using a fraction bar. Okay, switch over to my paper. That's saying, take f of x. F of x is on top. That's a 3x plus 2. G of x is on the bottom. That's a 2x minus 5.
Well, heck, that's the easiest one.
Well, if there was something that could be factored and you could cancel, you'd have to do that. But both of those things are linear functions. There's no factor. You can't factor and cancel. They can't be factored. So what do you conclude? There it is. The easiest one. Except for the domain. For the domain,
there's no square root.
There's no square root, so you're not going to get imaginary numbers. But I see a fraction bar, What do you not want to have happen? Okay.
Don't want that 0 at the bottom.
Notice I'm putting little d colon, so you know those negative infinity to positive infinity, that's the domain for f plus g, f minus g, and f times g. But for f divided by g for the domain, you cannot let the denominator be 0. Remember, we said a number divided by 0. That says no, it is undefined. So 2x can't equal 5. And divide it by 2. So, I'm almost. So x cannot equal 5 halves. So the domain for f divided by g, if I were going to write it out in words, I'd write all real numbers except for 5 halves. All real numbers except 5 halves, but they're going to want interval notation. So how do we say that? Do y'all remember that? We were doing it there at the end of class 2 weeks ago.
I'm going to show you how you used to be able to write it, but they don't let you do that anymore. Well, you never could with Pearson. But back in the olden days, you'd say all real numbers except for what? 5 over 2. Can y'all
You
see
put the
that?
5 over 2 in set braces,
Yeah.
though. Mm-hmm.
But that's not how we do it anymore.
I remember, if you look back in old-fashioned, old books, and they're finding domains, you'll see notation like that, okay? That's a set operation saying remove the number 5 halves, but we can't do that. How do we say it? Do y'all remember how we determined the interval notation? We'd think of a number line. Here's my number line. We don't want 5 halves. That's like a denominator cut point. You don't want that number, but it can be anything else. I remember doing this before spring break. Yes, okay, good. So how do we say that?
Open parentheses.
Okay, open parentheses.
Negative infinity.
Negative infinity.
5 over 2.
What goes after the 5 over 2?
Close parentheses.
Okay. Do not use a bracket. A bracket would say you're using that number, and then you got to have a union, and then you want to say all the numbers to the right of 5 halves.
Open parentheses. 5 over 2.
Yes.
Comma. Positive infinity.
And what always goes after? Okay. There's the domain. Oh, here. Here's the one for division. There it is for multiplication. So f plus g, f minus g, and f times g, they had the same domains, didn't they? All real numbers. But the quotient, you couldn't allow the denominator to be 0. Any questions there? Any questions on my work? Oh, okay. So he's starting to type in.
Oh, no. There, go ahead.
Any questions on my work here?
So to add, you just combine like terms. To subtract, you distribute the minus, then combine like terms. FOIL for multiply, and then division isn't hard at all, just f over g, except that denominator
cannot be 0.
So the domain is what's hard on the division.
Okay, go ahead and type those in. 6x squared. Get out of that exponent. Minus 11x minus 10. And here it's a fraction. On top you have 3x plus 2. On bottom you have 2x minus 5. And now we have to write or enter the domain.
And years ago when I was speaking at a Pearson thing, and I told them, y'all should make a little hot button that's just parentheses
Negative
infinity, comma, infinity. And they thought I was crazy.
Well, they laugh.
Yeah.
No, copy it. Wait,
am.
now, hold on. No. Don't
Oh.
try to do it like that. Do it like that. Control C. There.
So he just copied it. You can copy it before you say check answer. After you check it, you can't. And then we'll just paste it in. Control V. Check answer. See, isn't it nice if they just had one that said negative infinity to infinity? Control V. Okay, but now this last one. You know what? I shouldn't have done what I did.
Yeah, shrink it back.
Parentheses.
Negative infinity.
Comma, what is it?
5 halves.
Is that wrong?
Yes.
Yes.
Look where you put that parenthesis.
I got to get out of that denominator. Right arrow. Parentheses.
Union.
Parentheses. 5/2.
Get out of the denominator.
Don't put the comma there in the denominator. It might count it wrong.
It probably will.
So get out of that. Then put the comma. Infinity. Close parentheses, huh?
Any questions?
Oh gosh, Tim, it took you 21 minutes to do the first problem.
Now difference quotients.
This is just, there was one problem over operations of functions. We're going to have two problems over something called difference quotients.
The difference quotient is just a, I don't need an S there. The difference quotient is a fraction that pops up in the definition of derivative in Calculus 1. And you don't have to know the calculus part of the difference quotient. All you have to know is how to simplify the algebraic portion of difference quotient. The difference quotient, switch to my paper.
You're going to do a three-step. Okay. It's so important that they see the word difference quotient.
Oh, I was going to... There. Okay. The difference quotient is just the fraction f of x plus h minus f of x all over h. That itself is the difference quotient. Now go back to the problem. This is what we're looking for, but now, Tony, you say what you were going to say.
It's talking you through a three-step process.
Now look at number 3. On number 2, they talk you through because it's the first one.
A, B, C.
And number 3, look at this.
Doesn't give you the 3 steps. You got to know the 3 steps.
I'm going to use those 3 steps. Even on number 3, I'll break it up into pieces the way they do on number 2 to get that final answer.
Mm-hmm.
So on number 2, they give us the function f of x equals x squared plus 7. This is number 2. They give us f of x is equal to x squared plus 7.
And part A.
Okay, I know that. There. Okay, for part A, I don't have it. I'm not sure. We have f of x plus h. Part A, they want us to find f of x plus h. What they're trying to tell you to do, they're stepping you through this big messy fraction. The first thing they want you to do is find this little portion here in the numerator, f of x plus h. And we know how function notation works. 2 weeks ago, we saw how it worked. That's saying go to your function f. Wherever you see a variable, you're going to replace it with what's in the parentheses. So everywhere we see an x up here, we're going to replace it with an x plus h. So in place of that blue x, we still have the square, but we're going to replace that blue x with x plus h. We still have that plus 7 stuck on there. Go to your function f. Everywhere you see a variable, replace it with what's in the parentheses. So everywhere we see an x, we're replacing it with x plus h. And we're going to have to remember how we how we square a sum. X plus h squared. I'll tell you this much, it's not just x squared plus h squared. X plus h squared. I remember having to square a complex number in the second homework assignment. We had something like a 3 plus 2i, and it was being squared. And what did we do to square a sum? I'll give you a hint. We had just finished foiling. We had just finished a problem foiling when they did give us this problem. So what did we do? We wrote it twice. 3 plus 2i times 3 plus 2i. Don't write down that, okay? But do y'all remember doing that? It was one of the problems in the second homework assignment. It's the first time we ran into squaring a sum. You can't just square the terms individually. So for x plus h squared, here's my scratch work, and I'm going to write it neat. Right here's my scratch work. X plus h times x plus h. To square a sum, we write it twice. Here's something we should be grateful for. None of the problems have cubes. None of the difference problems have cubes, or difference quotient problems have cubes, because if they did, we'd have to write it 3 times. We'd FOIL it out, combine like terms, then we'd have to distribute another x, distribute another h. So really we should be grateful that they don't give us any that have cubes in the difference quotient. But as it is, first, we're FOILing this out. X times x is x squared, outer. X times h, here's what I'm going to do. If I have 2 letters in the same terms, I'm going to write the letters in alphabetical order. X times h, I'll put hx. You'll see why in a moment. What about the inner product? H times x is another hx. We have like terms here. If you'd written that as an xh and this one is an hx, you may have not noticed that they were like terms that could be combined. So my advice to you, if you have a term that has 2 different variables, put them in alphabetical order. And what's last? H times h, how will I denote that? H squared. Let's combine, well, there's not another x squared term, so we just have an x squared plus hx plus hx. What's that going to give us? 2hx. Now, that's the importance of writing them in alphabetical order. Unfortunately, if they're not in alphabetical order, people have a tendency to overlook that they're like terms that can be combined. So hx plus hx becomes 2hx, and I still have the h squared. If you're squaring x plus h, write it twice, FOIL it out. So, for part A, x plus h quantity squared, that became x squared plus 2hx plus h squared. What do we still have stuck on there? A plus 7. Generally, this first part is the longest part of the problem. And let me see. I'm going to box this in. Here's my answer for part A. X squared plus 2hx plus h squared plus 7. Now part B. I may as well type in that answer. I don't want to get timed out. So we have an x squared, get out of the exponent, plus 2hx plus h squared plus 7. Any questions there? Generally, part A is the longest part of the problem. Now look at part B. Part B, they're saying, take what you just found in part A and subtract f of x. We're simplifying that entire numerator now. And this, if you understand what they're asking for, part B is actually easier than part A. We want to take what we just found, f of x plus h, and we're going to subtract the original function f of x. If you that minus, this minus right here, it's almost acting like the old-fashioned subtraction takeaway. Take what you just found in part A, take away the original terms. This is algebraically. This is I shouldn't say algebraic. This is an algebraic way of saying take what you just found in part A and take away. That minus is acting like a takeaway. F of x is the original function. I'll get us started. Here's f of x plus h. We're going to take away these terms here. So right off, x squared, we drop x squared. What else are we going to take away? X squared minus x squared. There's something else that's going to disappear. No, because there's not an h squared up here to get rid of. You're taking what you have. You start off with the answer in part A, and you're taking away f of x. So the 7 is going to disappear. The x squared is going to disappear. All you're left with are the terms containing h. So that's an x squared. No, we took away the x squared. That's a 2hx plus an h squared. Ignore that squiggly there. I feel like I'm doing a poor job explaining this. Take what you found in part A and take away the original terms. So you took away the x squared, you took away the 7, leaving you only terms containing h. Any questions on my logic there?
So you're just taking away the x squared and the plus 7. Okay.
That's right. Okay, go ahead to the 2hx plus h squared.
If I'd written xh, would that have been okay?
That'd be okay, but I told him to write those letters in alphabetical order.
That's a good one.
H squared, yes. Okay, check.
And now part C.
We're finally ready to evaluate the difference quotient. They're saying, well, put it back over here. We're finally ready to simplify that difference quotient. F of x plus h. Oh, damn it. Darn it. I'll be quiet. All over h. Look at this top. F of x plus h minus f of x. Isn't that what we just found here in part B? So we just take that answer and write it down here on top. 2hx plus h squared. So you're taking the answer from part B. I'll make a note. And you're going to divide it by h.
This goes back to day 2, doesn't it?
Yeah. Well, we could factor and cancel. I think the easier way to approach this is to pull the old trick of splitting up. Take the 2hx, put it over h, 2hx over h, plus take the h squared and put it over h. Remember I said In part B, the only terms you'll have left are the ones containing h. So everything on that top has to contain an h. So to divide by h, just split the terms up. You can cancel an h here to give us 2x plus, what are we going to have here? What's going to happen? One of the h's cancels, so we no longer have an h squared there, it's just an h. So 2x plus h is my final answer. Any questions there? If you view an example, they're going to show steps and be distributing, and experience shows when students start doing that, showing the messy manipulation, they start messing up. I think it's better to understand what they're asking you to do there. Right here in part B, that's the key. You take what you found in part A, you take away the original function. You take away the x squared. What else was in the original problem that you wrote down? A 7? Take away the 7. The only thing remaining is 2hx plus h squared. And as I said, here in part B, the only terms remaining must contain an h.
So you'll cancel down
here. Mm-hmm. Any questions there?
2x plus 8. Now,
even if they ask me to simplify a difference quotient, I'm going to break it into A, B, and C. Even if they don't ask me to do that, I'm going to first of all find f of x plus h. That's generally the longest part of the problem. Then take away the original terms. Finally divide by h. Any questions there?
Well, can I add something?
Yes.
The lazy man's way, if they don't ask A, B, C, once you've gotten to this part right here, x squared plus 2xh plus h squared plus 7. Once you have the f of x plus h, to do the take away f of x, take away the x squared, take away the 7, there's part B. Now divide by h.
Put it all over h. I see where you're going with that, Tony. I like the way you're thinking. So you can cancel, that's a 2x, plus cancel an h. You still have an h remaining.
But looking at the work there, oh my gosh, what the heck did you do?
Oh yeah, I think this is neater than the stuff I have
Oh, I
here.
know this is neat, but wait, what, you just marked out stuff and okay.
They marked out the stuff that didn't have h's, the original terms, and then divided each of the remaining terms by h. Okay.
Now let's do one where you don't have the A, B, C given.
And then I'm going to try to do it, a little shorter. This is number 3. Oh, they give us, okay. F of x is equal to 3x squared plus 2x plus 1. And they want us to find f of x plus h minus f of x all over h. Okay. Oh, wrong thing. There. Well, I'll start off with the f of x plus h. Okay, so f of x plus h. That says go to your function f. Wherever you see an x, replace it with what? Wherever you see an x, you're going to replace it with? No. Go to your function f. Wherever you see an x, replace it with
3 and then parentheses.
Okay, so
Okay,
you're
you're
replacing the x with x plus h.
Yeah.
Okay, so 3, we're replacing each of the x's with x plus h. And we've already done the x plus h times x plus h, but y'all seem so reluctant. Normally I just look back at my scratch paper and say, what did we get? But y'all seem so hesitant there. We squared the x plus h on problem 2. We got to use it again here in problem 3, and it might be good for us to do this multiplication again since y'all sounded so reluctant. X times x is x squared plus outer hx, good, inner, another hx, hx, last h squared, and what's that going to become? X squared plus 2hx plus h squared. So we just now squared x plus h. Now this problem's more involved than that previous problem. There's something else there on that term. What is it? The 3. We have a 3 in front of here. Y'all know what to do when you have a 3 in front of that set of parentheses. What are we going to have to do? Distribute to give us a 3x squared. I'll get us started. Next, 6hx. Next, what else? Plus 3h squared. So we've just now simplified that first term, 3 times x plus h squared, quantity squared. I think my microphone's going out or something, even though I have new batteries in it. Is it on? Yes, okay. What about this second term? This is easy. What are we going to do here?
You distribute.
You distribute to give you 2x plus 2h, and we still have something else stuck on there. A plus, wait a minute, what do you say? Plus 1, right.
Now, you've done the hard part.
This is the hard part. This is the hard part. Now, we want to simplify the entire numerator.
Subtract f of x.
We're subtracting f of x now.
Let's do that in red. I'm going to do it without any work.
Oh, okay.
Subtract f of x. So take away 3x squared. In red, what am I going to do?
Mark it out.
Mark it out.
Every term in the original function is being subtracted off. What else is going to disappear? What else will disappear?
Plus 1.
Okay, the plus 1's going to disappear. 1 minus 1.
So
anything else?
What have we not marked out?
The 2x. Everything in the original polynomial function is disappearing. As I said, the only terms remaining should have what letter? H. So I'm going to have to simplify. I'm going to write it. Okay, I just can't. I got to. Okay.
Just any of the old videos.
Okay.
Out there.
So what have we got? We have 6hx plus 3h squared. What else was left? What else do we have left from f of x plus h minus f of x? We have the 6hx, the 3h squared. Anything else? the plus 2h. And we want to divide it by h. Just put each one of them over h. Cancel, cancel, cancel.
That's nice.
What have we got? Here, what do we have left as our first term? Just 6x, I agree. The second term? 3h, I agree. Last here? Okay.
So,
If you understand what you're doing, it makes the algebraic manipulation much easier. If you understand what they're asking for, take what you found in Part A and take away the original terms.
that's what we did here with the 3 red.
And that's what he was doing right here with the 3 red slashes. And then divide every term by h. Any questions there? Now, if this were a calculus class, we then begin asking ourselves what happens to this expression as we shrink the value of h down to 0. But we don't have to worry about that. All we have to do is simplify difference quotients in this course. 6x plus 3h plus 2.
6x plus 3h plus 2.
Yes.
So when it doesn't have A, B, and C,
I still do the same thing. Find f of x plus h. I then subtract, take away the original terms, but I just did that. Mark off the original terms. That's quicker. And then, technically, I could have just gone over h, over h, over h. I didn't even have to show that
I
step
think some
there.
of the old videos, you'll see me doing it like that.
Okay, did I answer your question? So we've been going for 48 minutes, and we have done 3 problems.
Oh, wow.
Oh, wow.
Okay. So we've done the operations part of the assignment. That was problem 1. We've done
Difference quotients. That's
That's
problems
problem
2
2.
and 3. But we're going to go all the way down. We're going to do every problem down through number 11. So hopefully the rest of
This
these are going to
rate
get
we-
shorter.
Tim, I posted this
Oh, good for
as a
you.
Canvas file, so you can
Okay.
pull it up at the end of class.
Oh, I will. You know,
Okay,
I
so-
will.
You're going to define.
Composition of, okay, there are 3 topics in here in this class. Addition, subtract, the operations, addition, subtraction, multiplication, and division. There's difference quotient. Now we're ready for composition of functions. Composition of functions is a new operation that's unique to functions. It can't be applied to the real numbers or imaginary numbers. Addition, subtraction, multiplication, and division, you can just apply those, have their basis in their origin just with real numbers. But composition, it only works with functions. They need a symbol to represent composition, and when they were inventing this, they decided on a little I think it's a pretty nice symbol, pretty smart symbol. F composed with the G of X. It's F, a little o of G.
It looks like fog.
That is defined to be F of G of X. Composition of functions is just repeated use of function notation. This is saying take G. We know how function notation works. You take what's in the parentheses and plug it in for the variable. Just like we took what's in the parentheses, plugged it in for the variable. This is saying take G of X, plug it into the function F, and that's not the same thing as G composed with F. That would be the G is on the outside, and f of x is on the inside. When you're writing composition notation without the little o, the outside function is the function that goes on the outside. The inside function It's the function that goes on the inside. Let's look at number 4.
And of course, the very first problem doesn't use f and g, it uses f and h. Okay.
Okay, that's okay. I don't have a problem with h.
No.
I'll be honest. I don't have a
Except when you're
problem.
working with fog and golf, they should use fog and golf
So
rather than
what
hot.
I'm hearing is that once I succeed in taking over the world,
H will be okay.
it is.
Well,
It's a variable,
it's a
but for a composition of functions. What?
Fog and golf, f and g only.
Okay. Are you adding that to my list? Oh no.
Yeah, I've already added
Shit. H of x. Negative x, what is it? Plus 1. You know, you're right. I never had a problem with that h of x, but you're right. It's annoying.
It is.
Oh, and what do they want? They want.
5.
Okay.
Saying fog and golf and half really annoys someone in this classroom that's sitting right beside me. And so that's what I'm saying. But really, by the time you're through with this assignment, you're going to see the phrase, the words, fog and golf.
Is golf a word?
I just said it, and you wrote it. You see it a lot, okay?
Let's find the dictionary and look
In
it
2
up.
years' time, if someone asks you, did you discuss composition of functions
Hell,
in
in 2
Mr.
weeks' time.
Precella's class? You won't remember that. But if they say fog and golf, does that sound familiar? You're more likely to remember that. And
Okay.
you'll agree
Okay.
with me at the end of class.
Okay, here we go. Let me move my paper up. You should be thinking to yourself, good. It must be pretty short, or I would have started on another page, right? I wouldn't have. I try not to spread the problems from one page to the next in case you haven't noticed that. H is my outer function. I'm going to write this stuff without an O. H is on the outside, and on the inside, we have f of 5. We have f of 5. H is on the outside, the inner function is f, and it's being evaluated at 5. Look at this notation.
Oh, I was going to help you cover this stuff up. Okay.
Okay.
Next one.
Ignore. Okay, you used that.
No, you do that. Cover that.
Cover up for
Oh, okay, yeah. You don't need to do anything other than just cover up.
f of 5. F of 5. That's saying go to f. Wherever you see a variable, plug in what? 5. So here you have 5. You're going to replace that x with the blue 5 minus 1. We're just working on the inside. What's f of 5? What's that going to turn out to be? 24. 25 minus 1 is 24. But we still have these parentheses. And what have we got in front of those parentheses? We have the h. Composition is just repeated function notation. First thing you do, you plug the 5 into f. That gave you the 24. Now you want h of 24. What's h of 24? We're going to have to go to h, and wherever we see a variable, we're going to plug in. This says go to h. Wherever you see a variable, plug in 24. So we're replacing that x there with a green 24. What else do we still have? We've replaced the x with 24. We still have that plus 1. What's that giving us for a final answer? Negative 24 plus 1 gives us a final answer of negative 23. Any questions there?
In words, what are we doing? Take this number in the parentheses, plug it into f. Take that answer, plug it into h. Okay. Take this number, plug it into f. Take that answer. When we did that plugging in, we got what number? 24?
Mm-hmm.
Then take 24, plug into H.
There, that 25 minus 1, that gave me the 24. That's where we got that 24 there. And the final answer, negative 23.
Okay. Any questions?
Why does the H get dropped?
That's just, why did the 5 get dropped?
The F
the F get
okay.
dropped. It's just that function notation. This thing is saying, go to H, plug in a 24. So we went to H, we plugged in a 24,
And there's
negative 24
H
plus
right
1. Once you plug in, there's no H remaining.
Let's see. Oh.
You know
this is a
something?
nice
I think
one.
we need to do another. I'm going to make up an example time.
Okay. Then use on the side. Oh, no.
Oh, okay. I'll do it right here.
I thought you were going to use the F and H.
I
Maybe
am.
you should have.
I am, but I'm gonna no. I am gonna do it, but I'm gonna make it. I'm gonna do it on a separate page. Okay, I'm making up my own example. F of x is equal to 5x minus 1, and g of x is still negative x plus 1. It's the
G
same.
instead of H.
Oh, you're right. Yeah, you're right. I better use H. Since they used H in the previous one. That's an H of x. A moment ago we found half 5. H composed with F of 5. Let's go in the opposite direction. What do you think? Are we going to get the same thing?
Write down what you're going to find.
We want to find
Is FOH
F
a word?
composed with H.
What is that? Pho?
Hey, that's the Vietnamese dish, isn't
Spelled
it?
differently.
Yeah, you're right. Okay.
In words, could you tell someone in words what you got to do, how you do this? Suppose you couldn't write and someone was asking you, how do I do this problem? You would say,
Take F and plug it into.
take 5.
Take 5 and plug it into. Where does 5 go? Oh, no. Remember how it works. It's X goes in, you're working your way inside out. Here we took the 5, we plugged it into F. We took that result, we plugged it into H. So here we take the 5, we plug it into H. So here's H. Let's plug in that 5 there. So you're going to have a negative 5 plus 1. What's that giving you? That says plug the 5 into H. So you get a negative 5 plus 1, which gives me what?
Mm-hmm.
Now we take negative 4 and plug it into what? F. Take the negative 4 and plug it in there. So we have a 5 times negative 4 minus 1. Okay, a negative 20 minus 1 is a negative 21. 5 went into H. That gave us a negative 4. Negative 4 went into F. That gave us a negative 21.
Take the number in the parentheses, plug it into the function beside it, H.
Whatever you get, plug it into the function that's beside the H. Any questions there?
Now,
Operations are classified as commutative or not commutative. Addition is commutative. A plus B always equals B plus A. So, commutative. That means it doesn't matter the order in which you add them. You're going to get the same thing. What about subtraction? I'm going to classify everything as commutative or not commutative. All the operations. We have 5 of them. Is subtraction commutative? Does A minus B always equal B minus A? No, usually it doesn't. What about multiplication? Does A times B always equal B times A? Yes.
2
So
times 3, 3
2 times 3, 3 times 2, always. What about division? Does A divided by B always equal B divided by A? No, as a matter of fact, it usually doesn't.
The only way would be if A and B were equal.
And not 0.
Yeah.
So we have this new operation, composition.
So-
Where is that going to go? Is it going to go commutative or not commutative? Commutative. Does F composed with G always equal G composed with F? You're right. Does F composed with H always equal H composed with F? Did we get the same thing here? Actually, we came sort of close, but they're not equal. Composition of functions is not commutative. If they ask you to find F composed with H in a problem, and you accidentally find H composed with F, you're probably getting the wrong answer. The order in which those functions are written is important. Composition is not commutative. So if they ask you to find G composed with F and you find F composed with G, you're getting the answer wrong probably. Occasionally they're equal, but most of the time they're not. Any questions there? Remember we looked at tables at functions in terms of ordered pairs and assignments. Look at this. So number 5, they give us 2 functions and they're using tables to represent the functions.
Instead of the formula.
Instead of the formulas, they're giving us tables. Let me write these tables down. It's going to take me longer to write down the tables than it will to do the problem.
Do you remember that function notation? What's G of 14? How do you find that?
8 and 12.
You go to G.
7.
Now,
Okay, and we have 2 tables.
I'll call out the numbers straight across.
Okay.
3, 14, 10, 20.
Down here.
5, 12, 8, 21.
Okay. Switch over there. Oh, what do they want us to find?
Oh.
I wrote down the without
Fog 14.
F composed with G at 14. Okay, switch back to the paper. Let's make sure that we understand how these function tables work. The top row is X, the bottom row is Y. This is saying F assigns 5 to 7, 8 is assigned to 12, 12 is assigned to 9. Here's the function G. 3 is assigned to 5, 14 is assigned to 12, 10 is assigned to 8, and 20 is assigned to 21. So, looking at this notation, you have to remember how the notation, the order in which you use that notation. That's saying, I'm going to write it without the little O. That says F of G of 14. There's no equations to plug into. Use the table to find the value of G of 14. The table G assigns 14 to what number? You go to G, 14 is assigned to 12. So 14 is assigned G of 14. G assigns 14 to 12. Table G assigns 14 to 12. We still have the F sitting in front. What's F of 12? Go to table F. F assigns 12 to what number? I heard it say it, 9. Table F assigns 12 to 9. For my final answer. The number in the parentheses, that's the top number. They're asking you, What number does F assign 12 to? Table F, 12 is assigned to 9. So our final answer is 9. Any questions there?
He's written down stuff, but there's really not a lot of writing to do. You look, okay.
G assigns 14 to 12. F assigns 12 to 9.
You could do this one.
I'm going to make up one. Type in this answer. I have a good one I'm going to make up. I have one I want to make up using the same table here, okay? 9. Now come back here. I want to find, this is tricky, okay? This is an example. We're using the same tables. I want to find F composed with F of 8.
Don't look at the green G table.
Look at that. We're not using G at all. F composed with F at 8. This is easy then. What's the outer function? What letter am I going to write? F, okay. What's the inner function? Okay. So go to the F table. F assigns 8 to, we come to the F table. 8 is assigned to 12. I agree. We still have that F sitting on the outside though. F assigns 8 to 12. Now we want F of 12. What does F assign 12 to? Okay, you go back to the F table. 12 is assigned to 9. Did y'all follow my logic there?
And here's one just on the side. How about fog 3? Let's just do it, trying to just look at the thing. I'm not going to write out a lot.
Okay.
You start
right here.
Circle in green.
Green, okay. We have G of 3. G of 3.
That's the green table.
Go to the green table. What's G of 3? The table G assigns 3 to, I couldn't hear you, 5. So G of 3 is 5. We still have the F in front of it. So we're going to have to go to the F table. The F table assigns 5 to 7. Okay.
Now see how we're getting these? We're trying to write stuff down to show our thoughts, but there's not a lot to write down. Okay?
I think there's another table problem. Look at number 6.
Okay. I think it's that one you did. Can you do this one just looking at it? I'm going to do this.
Make it
I'm
bigger.
going to make it bigger.
Hey, they give us 2 tables, and this is like, that must be what I was thinking of, okay?
Yeah.
Because look at this. Look at what they're asking us to find. F composed with F of 7. What are we going to do with the G table? Are we going to do anything with it? No, we're only using the F table.
Let's pretend that G table ain't there.
Okay? Think your way through it. You're looking at the F table. The F table assigns 7 to 5. The F table assigns 5 to 8. Maybe I better write something down here, okay? They seem... F composed with F at 7.
Oh, we're going to write it down.
I better write down the little table also.
Oh, yeah, just write down the F table.
Yes, but I need to see the F table.
Oh.
I don't know what's out. Okay, so here's X, and so X and F of X.
5, 7, 11.
5, 7, 11.
8, 5, 6.
8, 5, 6.
Okay. So now you can point.
I can point. F of 7. The F table assigns 7 to 5. We still have this other F sitting out there. What's F of 5? Go to the F table. What does it assign the number 5 to? 5 is assigned to 8 for my final answer. Any questions there?
This one that, there's really not a lot of writing to it. 8. Any questions there?
Okay. Okay. We can find the composition of of two functions at a number gives you a final answer. That's a number. 4, 5, and 6. The final answers were numbers.
And
but
by
look
that,
at this.
You mean first 4, 5, and 6. Then you're finding there's a number here in the parentheses. 14. What was it? 5.
The composition at a number gives you an answer that's a number. A composition at x gives you a function of x. So this is number 7. We have two functions. F of x equals 8x minus 8, and g of x is 9 minus 3x. And they want us to find, f composed with g of x and g composed with f of x. We'll start off f composed with g at x. But realize your answer is not going to be a number. It's going to be a function of x. Switch.
Do you remember my arrow way?
I do remember your arrow way. Okay. This is saying take g of x and plug it into f, wherever you see a variable. So you're taking g of x and you're plugging it in to f. So what have we got? We have an 8. Replace the x with the pink 9 minus 3x. And I still have the minus 8. You're taking g of x and plugging it into f. You took g of x, plugged it into f. Well, we have to reduce this. We can simplify it by distributing. Distributing the 8, we'll get a 72 minus here 24x, and we still have a minus 8. 72 minus 8, that's a 64 minus 24x.
Can we get a 40?
Can we combine the 64 and the 24? No. Okay. It just dawned on me. Suppose they said yes. Then why did you ask that question, Tony? I'd go on. I would have been just blissfully ignorant, thinking y'all know that you could have combined it, but they know. Okay.
There's not an X on the 64, so.
Now, if you wanted to write it as negative 24x plus 64, you could do that. Mm-hmm. Okay, but I think I'll just type in 64 minus 2x.
So that's fog x. Oh, wait. What did I do wrong? Oh.
24.
Oh, I didn't type the 4. My 24x. Now find golf x. It's best to write down the whole problem first.
You're right. Let's write it all over again.
F of x.
F of x is equal to 8x minus 8. And g of x is equal to, we're still using the same f and g, but for illustration purposes, I think it's best to recopy them.
And
Now they want us to
golf
find
x.
G composed with f of x. G composed with f at x. That's saying take the second function, f of x, and plug it into G. So you're taking f of x and plugging it in to G. You're taking f of x, plugging it into G. So we have a pink 9 minus 3,
Which is not 6.
and then we're replacing the x with the blue 8x minus 8. Any questions on our logic here? You take the second function, you plug it into the first. You take the second function, plug it into the first. So the second function was f of x, we plugged it into the first function, g. And there's only one correct next step. What is it?
Okay. Distribute.
Distribute the negative 3. You can't distribute a 6. You remember the order of operations. You multiply before you add or subtract. Do not subtract 9 minus 3. So we're going to have a 9. Let's distribute that minus 3. Negative 3 times a positive 8x gives me a minus 24x. What else are we going to have here? Negative 3 times negative 8 gives me a I agree. So we have 9 plus 24, that's a 33 minus 24x.
Or negative 24x plus 33, however you want to write it.
Right.
Is it clear what we're doing with these arrows? You're plugging up here, G into F. We plug G into F. Here, you're plugging F into G. Plug F into G. Let me write that down. I think the next one is actually an even better learning example. 33 minus 24x. Same instructions. They look different. Oh wow, there's a square root. There's a square root in this one, so it's got to be harder, right?
Number 8. We have two functions.
I'm checking.
F of x equals 8x plus 1. And g of x is equal to the square root of x. F of x equals 8x plus 1. G of x is equal to the square root of x. We're asked to find f composed with g of x and then g composed with f of x. Let's find both of them and then we'll type in the answer. First of all, f composed with g of x. F composed with g of x. That's saying take g of x and plug it in to f.
Could y'all draw the arrows?
So you're taking g of x and you're plugging it in to f. So we have that blue 8. What are we going to have in place of that blue x?
A red.
Okay. What else are we going to have stuck on there? Plus 1. And there's nothing else you can do with that. There it is.
Remember,
F composed with g of x equals 8 times the square root of x plus 1.
Remember years ago a student said, it looks like you're just writing down the answer. Yeah, I'm drawing a few arrows and writing down, he is, writing down the answer.
Now, we'll go the opposite direction with your little circles the way I do that.
Oh yeah, forget it.
I said let's
I forgot.
write them all.
It's best to recopy it.
Yeah, because with the little circles it gets sort of messy. I'm just
the
recopying the
arrows and
the two functions they gave us.
And now
We need G composed
golf.
with F. G composed with F at X. So that's saying take F of X and plug it into G.
So you think, okay, take F of X.
So take F of X and we're going to plug it in over here into G.
So in words, if someone asked you, what are you doing here? You'd say, I'm going to replace that red X with what?
What am I going to have in place of that red X?
A blue
8X plus 1. That's right.
That's the people.
Okay, those of you in the peanut gallery, y'all have been quiet today. Y'all have been quiet. Any questions?
Maybe lift up your microphone.
I nearly set up over there when we were having trouble with this camera. Maybe on Monday, maybe I'll do that. Maybe we'll set up over there.
No. Oh, wait. Notice how fog doesn't equal golf. You see, look at this first answer.
Here's
Not
the
same
second.
as this one. Let me type these answers in. 8 square root of X, get out of there, plus 1.
Now, look at how he's going to tell him what's the first thing. Show him what you need to type. Show right here on my paper. Here's what he needs to type. What's he going to type first? The square root goes first because everything is underneath that square root. Any questions there?
I think this one does a really good job. And just looking at the finished product, well, okay, what the heck are you doing? Drawing some arrows and stuff, but I think it works really well.
Number 9. Okay, f of x is equal to the square root of, is that a 6x? These are my replacement glasses. My other glasses just broke the other day for no reason. I was just sitting down and they broke. And I'm still trying to get adjusted to...
Oh, I didn't. You know the instructions.
I know.
It's fog X and golf X.
So this is saying take g of x, plug it into f. Take g of x and plug it into f. So we're going to have the square root of 6. This is going to be more involved, though, than the previous one. There'll be a little bit more work because we're going to replace that x with what? 1 over x. And remember, what's 6 times 1 over x? Don't say 6 over 6x. That's like you're multiplying 6 over 1 times 1 over x, which gives us what? 6 times 1 is 6. 1 times x is x for the square root of 6 over x. Any questions on my logic there? So the first answer, it's a square root, and you have a fraction underneath it, 6 over x. Go ahead and type that in.
Square root of what was it, 6 over x?
Yes.
Why did they leave such a big space here? You used to be able to move this over. But like you do
You can
here.
just collapse it.
I know, but then you can't. If you want to skip around.
Okay, now we have to find g composed with f of x. G composed with f at x. G composed with f at x. Okay. Okay, let's follow the little circles. This is saying plug f of x into what? G, I agree. We're going to plug f of x over here into G. So we have a 1 over, what are we going to replace that x with? Okay, the square root of 6x. You may remember at the beginning of the semester we didn't leave the square roots in the denominator.
I bet they don't remember.
But
we did it on day one and never did it again.
But there's really nothing wrong with that square root. This is where they're expecting you to stop right there. If we rationalize it, we'd get the square root of 6x all over 6x. I think this looks better than what you get as a rationalized form, and Pearson thinks so also. Go ahead and type that in.
1 over the square root of 6x. Oh, what did I do? 60, okay. 1 over the square root of 6x. Made it a little bigger. Any questions over there? Wow, this finished product looks terrible. All this, what the heck is going on? This is one of those things, just looking at the finished product is not the best way. If you know someone that missed today, tell them watch the video. Okay?
Any questions there?
Oh wait, what did I just do? Okay.
For f of x equals 7x minus 4 and g of x equals 1/7 times the binomial x plus 4, find f composed with g of x and g composed with f of x. Then determine whether f composed with g of x is equal to g composed with f of x. Wait a minute. Why are they asking that? Look back at number 9. Look at my work.
Does fog x equal golf?
There's f composed with g and g composed with f. We can just look at your answers. I mean, the MyLab answers. It's cleaner, okay? Do you not usually expect the answers to be the same? Look at number 8. Look at number 8. Were they the same? What about number 7? No? So generally, you don't expect them to be equal.
Because of what you wrote about the commutative stuff.
But it's possible they will be. The mere fact that they're asking, are they equal, makes me think, wait a minute. Maybe this is one of those special cases where they are equal and they want to draw attention to the fact that here's a case where they are equal. I don't know. Let's see.
But
Number 10.
It's the same stuff we've been doing. It's just one more question at the end, yes or no?
Okay. Number 10, f of x is equal to 7x minus 4, and g of x is equal to 1/7 times x plus 4. I want us to find f composed with g and g composed with f.
So the first stuff is basically the same thing we've been doing with the arrows, and at the end we say yes or no. Did we get the same thing?
F composed with g. That's saying take g of x, plug it into f. Take g of x, plug it in to f.
In place of this blue x.
So we have the blue 7, and it's going to have to be multiplied by that red 1/7 times x plus 4. What else do we have stuck on there?
Let's see.
There's something else I have to write on this line.
Yeah.
The minus 4.
And you
We
asking
replace
that
the
because a lot
x
of
with
times-
this stuff here, and then minus 4. Don't let this repeated multiplication upset you. You multiply from left to right. Look at what's about to happen. 7 times 1/7. You're multiplying from left to right. What's just canceled out? The 7's just canceled. So all you have to distribute is what? What are you going to distribute over the x plus 4? The 1. There and there. 1 times x plus 4 is just x plus 4. But I still have a minus 4. Oh, it doesn't work out nicer than this. What's that going to simplify to?
X.
Just x. So f composed with g of x reduced to x. I wonder if g composed with f of x is going to reduce to x as well. If it does, if everything cancels out except for x in both directions, then yes, they are equal. If we get something other than x, then that final answer will be no, they're not equal. And generally, most of the time, they're not equal. F composed with g does not usually equal g composed with f. There are occasional times. Okay, f of x, that's 7x minus 4.
Just recopying the problem.
I'm just recopying the original problem because it gets so messy drawing those circles.
And arrows.
Arrows and circles, yeah. Now we found f composed with g. Now we have to go in the other direction with g first. G composed with f of x.
Hey, wait just a second. See, the instructions tell us, find the f of g, then find the g of f. Oh, wait.
Type in that answer, by
Oh.
the way.
What was? Oh, yeah,
X.
I know. X. I can
Everything
remember
canceled
that.
out except x.
So now it's telling you to find the g of f.
Okay.
Oh, and did you hear how I worded that? I did it just out of habit. I don't usually say fog. My habit is to read that little circle as of. F of g of x. And yours is to say f composed with.
Yes.
And then to annoy you, I'll say fog and golf.
That's why I say composed with.
To annoy me?
Yes.
Oh, okay.
Okay. Okay.
Teaching tips. For future teachers, if you just do what, if you're teaching with another teacher,
Do what annoys the other teacher. Good teaching tips from Anthony and Timothy Precella. This is saying take f of x and plug it into g. So here we're going to take f of x and we're going to plug it in over here into g. So we have a 1/7.
why don't you go to write the plus 4s?
Yeah, I have a plus 4 stuck on there. It's inside the parentheses, you see. But what am I going to write here in front of that plus 4? I couldn't hear you.
I heard him.
But if I can't hear him, then the other class, the rest of the class can't
Oh.
hear him. And I am half deaf.
Now, how is this going to simplify?
Hey, look at that. Look inside the parentheses. Something's about to happen. What's going to happen inside those parentheses?
We're gonna get rid of the 7.
Not this. Oh, yeah, you're
Yeah.
right. We're going to get rid of the 7, but there's something else we're going to get rid of.
The
We'll get rid of
fours.
the negative 4 plus 4. That's gone. And then what did you say we can do with the 7?
We can get rid of 4.
So what are we left with?
Just
1 times
of x.
x.
Uh-huh.
Well, look at that. F composed with G and G composed with F were equal. So it turns out, this is the first time we've seen this happen. F composed with G of X does equal G composed with F of X.
It did it on problem 7, 8, or 9. But it did here. Notice how everything just starts canceling out.
They're trying, here on problem number 10, they're trying to prepare you for the, let's see, we have zeros and then inverses. The next assignment, we have zeros coming up, and then after zeros are polynomials, we have inverse functions. Inverse functions are functions whose compositions always reduce to x. That's what they're trying to get us ready here for. That we can say f of x is the inverse is the inverse of g of x. And in 12 days, you'll find out what we mean by an inverse. But you already sort of know. If you find their composition, plugging them into each other, everything cancels out except for x.
Okay. Wait, so the answer to 10 was x.
And
yes or no?
Yes.
I wasn't answered.
He answered.
Oh, I did. X, yes. Let me make this smaller. So I think everyone's number 10 is X, yes. So
Why are you telling
I know
them
this
that?
way it'll encourage them to go home right now and do it, or to do the problems right now while they remember. Okay, 10, X, yes. They wait a week, they ain't going to remember me saying this, okay? So it's actually a good teaching tip. Like number 11. Y'all want to guess what the answer's going to be?
Has the same instructions. Find f composed with g of x, find g composed with f of x, and then they ask that mysterious question, are f composed with g of x, is f composed with g of x equal to g composed with f of x? One day I'm just going to break and just start saying fog and golf. It's just so much easier. Okay.
And they remember that then.
Of course they do, Tony.
No. I've had former students in seeing them out and about, and they'll say fog and golf. They remember they did fog and golf. They don't remember what that is, but they remember fog and golf.
In the 80s, I think Thomas Dolby had a music video with some famous physicist. He yelled science. And so for the rest of his life, people would go up to that poor man and yell science to him right in his face.
Yeah, it drove him.
It drove him sort of,
In the olden days, people say it drove him crazy.
Now you shouldn't say that, okay? But that's sort of what happened. And so just because they remember doesn't mean it's good that they remember. Just they remember your fog and golf. Here's the bad thing. When Dr. Alston said that, I remembered.
Oh yeah. He was the first teacher I ever heard that said fog and golf. I was, oh my gosh, can we do that?
Is it allowed to say fog and golf?
That was a graduate course then.
Mm-hmm. I remember it now. You're right about that. Okay, we need to find, this is the last one, so let's try to do it fast. I can't believe you have your ringer on,
I don't.
Tony.
It's yours.
Well, I can't believe you didn't turn you had to go get my phone for your own
I wanted to
purposes.
I had a purpose for it, so.
Okay, switch over. Here we are. I feel like this has been a messed up class today. This is saying take g of x and plug it into f. Take g of x and plug it in to f.
Put that arrow right there at the x.
I did. Okay.
Continue it.
There. So we have a cube root of, we have the 9, we have that plus 4. What's 9 going to be multiplied by? What am I going to put right here?
1 over 9.
Okay, so the blue stuff. 1 over 9x cubed minus 4 over 9.
Oh, this looks bad. You might be thinking that.
So, Let's simplify. The first thing we'll do, we need to remove the parentheses. I think things are going to start looking a lot better real fast. Distribute the 9. What's that going to give us? We're distributing the 9 here and here. In the first product, what happens?
Yeah, right. 9 over 1 times.
Okay, so that's 9 over 1 times 1/9 x cubed minus 4/9. Here's my scratch work. What's going to happen here? The 9's cancel. Here, 9's cancel as well. So what's the only thing we have left here?
Perfect. Yes. Y'all hear that? X cubed minus 4?
You say, well, suppose your problem doesn't have a 9. Suppose you have a 7 here and 9's down here. In that event, then no, it's not going to happen because these are trying to get you ready for inverse functions. In order to cancel out everything except for x, that number has to be the same as this.
So basically what you're telling them is the answer to number 11 is XX, yes.
Well, because you'd already told them that. Okay. Did you see what happened? This 9 canceled with those 9's, leaving us just an x cubed minus 4. Something disappears immediately. The 4's, I agree, so we have a cube root of x cubed. What's the cube root of x cubed?
What's going to happen with a cube root and a cube?
It's the same thing that happens with the square root and a square.
They cancel.
They cancel each other out, leaving us just x. In 12 days, when we're looking at inverse functions, the way these things cancel each other out is because they're inverses. One undoes the effect of the other. So, f composed with g of x reduced to x.
I'll wait to type in that.
Now let's go in the opposite direction.
No.
Oh, you want me to write the problem down first?
You were the one that told me way back. You need to write that problem down again.
I know, but we're running late. I've got to get to the catering gig. Those of you, you know I'm joking. I'm not a caterer, but I'm just dressed like a caterer today. I'm on my way to a fancy dress affair.
And I'm going to be one of the people attending the fancy
You are
dress.
not. You are not.
Wait, I'm confused. You actually
Golf
have something
bag.
or are you
No,
just kidding?
we're joking, of course.
I can never tell.
Oh, so we want to find
Golf x.
golf x. G composed with f of x.
Or g of f of x.
Okay, y'all, in the peanut gallery. I'm sitting over there tomorrow.
but tomorrow's
on Monday.
Thursday, so
On
that
Monday,
doesn't
I'm
matter.
sitting over there. Okay, so that they're so quiet. I need to be over there and liven them up some. Okay, so this is saying we're taking f of x and we're plugging it into g. I should have used a different color there. We're taking f of x and we're plugging it in to g. Y'all see what we're going to have? We have a blue 1/9. We have that cube. We have that minus 4/9. What am I going to write here that's going to be cubed? That cube root stuff, okay. The cube root of 9x plus 4. What's going to happen when we cube the cube root? So we really just have 1/9 times 9x plus 4 minus 4/9. So we cancel the cube and the cube root. Now we need to distribute the 1/9. Multiply here and here. What's 1/9 times 9x? What's that going to give us?
1x plus 2.
Okay, so the 9's cancel. That'll leave us 1x plus 1/9 times 4. Here, Tony, show 1/9 times 9 over 1. That canceled, leaving us just the 1x. 1/9 times 4 over 1. That gives me what? 4 over 9. 4/9. And what do we still have stuck on there? The minus 4/9. And then what happens?
Get rid
To give us a final answer of,
They're just not talking.
okay, x, okay.
We have that extra question. Does f of g of x equal g of f of x? Yes.
Yes, f composed with g of x equals g composed with f of x. And when we see that formal definition of inverse in 12 days, I'm going to be reminding y'all of that of this problem, 11 and 10. If they're inverse functions, their compositions.
Tim, wait, you're pointing and I'm here doing this.
Okay.
Wait,
Select yes, finish it off. Okay. There.
Okay.
Now, what was I pointing at?
I don't know.
What
I
was
saw
I
you pointing and saying stuff.
I was saying that in 12 days, when we formally define composition of functions as f composed with g of x equals g composed with f of x equals x, I'm going to remind you of these problems. These problems are inverse functions. When they're performed
consecutive
in either order, they cancel out everything except the initial domain value for our purposes, the variable x.
Now, before we leave, I think the next one is just a review. Is that right or not?
Oh, if it isn't, I'm doing it.
Oh, no.
Oh, it's a cut point.
Okay. What I wanted to show y'all is, have you logged into Canvas?
Is it something you need to record?
Yeah, I'm going to
Okay.
record it.
Go down, put student view. You've
Student
probably
view.
been timed out. Let's see.
Files. Look and see if there's a
Well,
file.
first of all, I want to look upcoming assignments. Notice we changed the due date on quiz 2 to March the 26th, and on March 26th, 1 week from today, that'll be in-class testing. Looking at files.
I was trying to do this on your phone.
I don't see it.
Oh, okay then. Oh, click here.
Oh, I know the problem. You didn't publish it.
Oh, you're right. Yeah. It's real easy.
Wait a
I'm
minute.
emailed
Wait a
it
minute.
to
Let
you.
me look.
Tim, I
No, it's
emailed
not
it
to you. I
I
don't see
emailed it to you.
Oh, that's great. Oh,
Right here.
There it is.
Okay, click this picture and make it big. Oh, well,
What
slow
is
up.
this?
I don't know what that is. Oh, yes, it is. It's the picture itself. Okay. Look.
Are we still recording?
Yes, because I really thought, look at this, follow my arrow. Oh, wait, I don't know. I like it the other way. How do I get it? Oh, full screen?
There.
Now, how do I make this?
Tony thinks this is so meaningful, okay?
Okay, f of x is the pizza, g of x is the pineapple. F, they didn't write fog, they just wrote f of g of x. That means plug G into F.
So you plug into pineapple into the pizza. So the pizza is on the pineapple.
No, the pineapple is on
the
pizza.
pineapple is on the pizza.
But G of F of X. Imagine the little arrows if I were drawing. You're putting the F on G. You're putting the pizza onto the pineapple.
Look at the big slice of pineapple there
with the little
pieces
slices of pizza. To me, I think that's, makes the point. And but
I
still.
do. I think I like it.
Okay, that's what I wanted to show y'all. before we call it quits.
And
I'm
I
gonna
had
stop
that
recording.
picture on my telephone. That's where you had to go.